All right, so we're going to do 1.2 application here. We'll probably do not every problem. I tend to do the odds unless there's a specific one that I know people get stuck on. And you can always come to question and answer time, and I will do the other ones in question and answer time. All right, so what do we have here? Okay, in your own words, define constant speed and provide an example. That's something you can do by looking at the live sessions or at the textbook for 1.2. When calculating the velocity of a moving object, you need to consider the distance traveled or the displacement. So make sure you have those formula sheets written down. And honestly, if you can print that formula sheet, it'd be nice because then right next to where you see delta D, right next to it in words, displacement. So that you can keep track of which one is which. And then on the SOL, obviously you won't have that, but hopefully seeing it on your formula sheet every day for the course, then it'll sink in. Hey, you are flying 2586 miles, so I'm going to go ahead and circle that. Remember, it's the circle of the givens is the system that I use, and you could call those givens the knowns too, circle knowns. So they jump right out at you. Okay, and this is miles. So I'm going to give that a D. From San Francisco to New York, that's probably extraneous information I don't need. An hour into the flight, okay? So 1 hour, I'm going to circle that as my time. Okay, sometimes it's not going to show up like a number. You are 600 miles from San Francisco. So that's another distance thing. So we're going to have to evaluate that further as we go on. What is your speed in meters per second? Remember, M is going to be meters, S is going to be seconds, not miles. Okay, miles would be abbreviated MI, even though you see miles per hour in the English system as MPH. But that is not what we're going to do when we're doing it in physics class. So miles is MI and meters is going to be M. And so I underlined my unknowns, the question, what I'm trying to find. Right. And so now I go on there and I find that speed's formula is distance over time. Okay, now we don't have an actual idea. We're hoping that that 2,586 is not as the crow flies, and that's the actual path the plane takes. But so whenever you see anything like this, you can say that you assume this is the path. Okay. And why is that, especially if you're going to be moving on to do FRQs in AP? These are your saving graces, being able to write that down. On any essay questions, if you were to write that down, I would also then make sure that I will take this as the path, even if it was the displacement. Okay, so always write down your assumptions. Now, what is my distance? We didn't actually make it all the way to San Francisco. So my distance is going to be 2586 minus 600. And I'm going to put parentheses around that just so it's really, really clear that I need to have that answer. Oh, wait, actually, do we not need to do that? Let me read it again. You are flying 2,586 miles from San Francisco to New York. An hour into the flight, you are 600 miles from San Francisco. Okay, we're going from San Francisco, so we've only crossed 600 miles. And what is the time? The time is 1 hour. Now again, what is wrong with this picture? It is not converted. We need to go from 600 miles in 1 hour, and we need to convert that into the same item in meters per second. So we're going to do our numerators first. Miles to meters. So 600 miles in 1 hour. Okay, and first conversion. I want to go from miles to feet. That's what's on my conversion sheet. 5280 feet are in 1 mile, and now I've canceled off the miles. Feet, from feet, 2 inches. In 1 foot, there's 12 inches. And in 1 inch, there's 2.54 centimeters. And let me go back and cross off feet, feet, inches, inches. And in 100 centimeters, there is 1 meter. Now, if you have other conversions on your conversion sheet, go ahead and add them. I'm doing the full out one, having the minimum number of conversions that you had to memorize. But if you have feet and meters, yes, use the feet and meters one, and you can add feet and meters into your situation. So when we get done with this calculation, we're going to have meters per hour. And so that is going to be 600 times 5280 times 12 times 2.54. And all of that divided by 100, because everything else is a 1, so it's basically going to drop out. So we have 965,606.4 meters per hour right now. And so that's meters in 1 hour. And what do I need it in? In seconds. So this time the hours has to go on the top to cancel. And the minutes here, there are 60 minutes in 1 hour. And now my hours cancel. So if you did dimensional analysis in chemistry, you got kind of in the habit to do this, but when we're doing these derived ones where you have units on the bottom, just remember to cancel, you're going to have to put that unit conversions on the top. So again, minutes is in the denominator here. So minutes is going to have to go in the numerator. And then seconds is going to go in the denominator, which is what we wanted anyway, right? Because we wanted our answer to be in meters per second. Meters in the numerator, seconds in the denominator. And in every 1 minute, there is 60 seconds. So we're going to take 965,606.4 divided by the quantity of 60 times 60. And we are going to get 268.224 meters per second. 268.2 meters per second. When you show your work, I do want to see you putting it into the speed formula, and I do want to see your conversions, but your conversions can be shorter. Just don't use Google to do a direct miles per hour to meters per second. Have at least one conversion the correct way, or the numerator conversion, and at least one denominator conversion. What does that mean? You could have said 965,606.4 times 1 hour over 3,600 seconds. That's fine, but I do want to make sure that you are getting your canceling in correctly. That's one of the biggest mistakes. And if you don't solve it now, then when we get into the higher level stuff, it's going to just compound things. So do make sure you're showing it in this dimensional analysis format. Okay, and if you need any past videos to review that, let me know. We can do some more. We did do one in the session last week. Okay, so I'm going to go ahead and clear now. Number 4, the pilot looks at the speedometer. Okay, so we went over that one in the live session. So try that one on your own, and I'll always give you some correction when you post it if you had any issue with it. But that answer is in the live session on 1.2. All right. You get in your car at 7:33 a.m. and drive 10 miles north at a constant speed until 7:45. So 7:33 to 7:45, that's 12 minutes, and you went 10 miles north. Okay. When you realize you left your homework on the kitchen table, you turn around and drive 10 miles south back to your house at a constant speed. And it's now 8 o'clock. So now it's been 15 minutes for those 10 miles. So you might have had more stoplights, or you were driving slower, something was different, and that's okay. We're talking about the average speeds here. Okay. And then finally, you get to school at 8:29. Okay. And so you left the house at 8 o'clock, and now it's 8:29. So the time for that segment is 29 minutes. And that was a total of 15 miles because that school was just a little bit further. So we just verified that that table was correct. What is your average speed? Okay, and that's talking about the path over the time. So you want the total distance divided by the total time, and that's going to give it to you in miles per minute. So make sure then convert. Do not forget to convert using your dimensional analysis formula. What is your average velocity? So when you look on that formula sheet, velocity is displacement, okay, or delta D over delta T. So how much total distance did we go? Well, we started at 0 and we ended at 15. Distance at the end point minus distance at the start point. 15 minus 0. I'm just going to put parentheses just so we're really clear, so you don't have an order of operations issue. And what is our time? We started at 7:33 and we ended at 8:29. So what is that? 29 plus 27 minutes. 56. Did I do that right? 56. Okay, and again, what is that going to be in miles per minute? So make sure you convert using dimensional analysis. Dimensional analysis. All right, number 7. If you looked at your speedometer, okay, again, we went over speedometer questions, so I'll leave that. Go try it on your own. If you're not sure, check the live session. Describe the direction of motion of the following objects based on their slope on the position time graph. So if you have a positive slope, we're going up like this. So what is happening? Okay, the motion is going away from the origin. Okay, so the motion is going away, and it's going to be constant velocity. It didn't ask for that, but I just want to make sure that we're really reiterating that so it gets stuck in your brain. Negative slope, what does negative mean? That means it's going down. So actually we have to start above the origin to do that. So it's starting away from the origin and it's going towards the origin. So number 8 is going away from the origin. Number 9 is going towards the origin. The slope equals 0, okay? So remember, undefined. That's when the slope is vertical, but we have horizontal. So the slope here is 0. And I'll let you work on solving what's happening for that one. Just wanted to make sure you knew which one was which. All right, number 11. The following table depicts the motion of the mouse as it runs rightward across a street. Create a position time graph. So when we're doing this, remember cumulative. So step 1 is at 0, 0 for the start. Okay, and then we moved in 1 second. We moved 1 meter, which goes where? Oh, time goes here, right? So we're going to have this in seconds. Make sure you label your units on the axes. And this one, you can label it as X or position or distance. You could do whatever you want there. Just make sure you tell me it's in meters. After 1 second, it went 1 meter. Now at 2 seconds, its position is 3 meters. So let's think about this. Which way is this one going? It is telling us the time and the position at that time. 3, 5, 4, 7. So it is not super clear on this one which way it's giving us, if it's giving us cumulative time. So I'm going to assume that this is actually giving us our x-axis and our y-axis directly, because it's going 1, 2, 3, 4. So it's going up in increments of 1. So then you would keep plotting here, time 2, position 3. And you would keep going at the end, and then do make sure that you do connect all the line segments so that you can describe them later on. So for this one, you don't need to do cumulative because of how it's listed. It looks like it is giving you the cumulative since all the numbers are increasing. That is my assumption. So if you did it the different way, just write down, you assume that that was for each line segment. You're going to see the graphs either way. And that is the end of that part. So have a great day.